The lesson for today, lesson 6.5, is on properties of logarithms. So in our previous lesson, we looked at how we can change from exponential form to logarithmic form. Today, we're going to look at some things that we can do with a logarithmic form to help us in future chapters when we're looking to solve an equation that contains logarithms. So a lot of what we're going to go through today, when we get done working a problem, it's going to seem like we didn't really get to a solution because all we're going to be looking at is applying these logarithmic properties. So starting off, just a general overview of the properties. We see on under the study tip here that our three logarithmic properties are going to mimic, in some regards, the exponential properties we learned about earlier in the chapter. So looking here, we have the product property of exponents, stating that we can, if we have a base, they used a to the m power times a to the n power, we can simplify that by adding the exponent, so it becomes a to the m plus n. Looking at the product property for logarithms, right, we have log base b of m times n. To expand that, looking right here, we can take log base b, the base has to stay the same, and then we add the two logs. Right, so log base b of m plus log base b of n. This can be useful when you're looking to solve an equation, and these properties work in both directions. So typically, we don't want to make our problem more complicated like we see here, but we can use what we see on the right side and simplify it down to what we see on the left. Sometimes when solving, it may be helpful to expand it out before we can solve. So looking over here at our exponent properties, we have the quotient property stating that if we have a to the m, the quotient property states that if we have a to the m over a to the n, we can simplify that by subtracting the exponents. Similarly, our quotient property for logarithms, we have that fraction, right? We have log base b of m over n, and we can expand that out using that subtraction like we saw over in the exponent property. We can take that logarithm and break it into log base b of m minus log base b of n. And then finally, we have the power property of exponents. We have a to the m power and then to the n power. We can multiply the two exponents and get a to the m times n. For the power property of logarithms, we take log base b of m to the n power. We take this exponent of n and we bring it out in front of the logarithm. So then you have n times log base b of m. Lots of letters and it's a little confusing. Helps to kind of see it in practice. So with these examples here, we see in the directions, they give us some approximations for log base 2 of 3, log base 2 of 7. What I want to practice here on these slides is using those three logarithmic properties to expand these logarithms. So here in this first one, we're going to use the quotient property. A lot of times the hardest part of this is figuring out which property I'm going to use. So I see this fraction here of 3 over 7. So that's a division. So I know quotient property is going to be used. So I can separate this out into log base 2 of 3 minus the log base 2 of 7. And you could, if you wanted to approximate this, you could subtract using these estimates up in the instructions, right? But the main thing here I want you to understand is how to expand using the properties. So the first one was quotient property. For the second one, we're going to demonstrate the product property. And in order to do that, I need to get a product or a multiplication. So I'm going to separate the 21 into 3 times 7. So I have log base 2 of 21. That's equal to log base 2 of 3 times 7. I just broke up the 21 into 3 times 7. Using the product property, I have this multiplication. I know then that I can separate that out into 2 separate logarithms added together, right? So log base 2 of 3 plus log base 2 of 7. You could then use those approximations in the instructions to estimate it. You could also pretty easily, with what we learned in our previous lesson, take the log base 2 of 21, enter that into the calculator, right? Log base 2 of 21, I can say log of big over log of little. So the log of 21 over the log of 2, and then that could get plugged into my computer or calculator. For example C, we're going to demonstrate the power property here. And I need an exponent. So I'm going to separate 49 into 7 squared. Right? So log base 2 of 49 is equal to log base 2 of 7 squared. The power property then lets me take that exponent, this 2 here, and bring it out in front of the logarithm. So log base 2 times log base 2 of 7. So that is an example using those properties to expand some logarithms. Here in example 2, we are looking at the natural log, that's the ln, so the natural log of something. Now, natural log goes with natural base, and we learned earlier in chapter 6 about that natural base e. So if you're looking at constantly compounding situations like population growth, we use that natural base e. So if I have an exponent attached to that natural base e, I can use the natural log to help figure out what that exponent would be. It's comparable then to natural log e. Natural log is comparable to log base e. It's used often enough that that's going to get its own button on a scientific or graphing calculator. So our same exponent or logarithmic properties still apply. So here in our example 2, they want us to expand natural log of 5x to the 7th over y. So just taking a look, I see a fraction here. I see a power here. And I see multiplication right here between the 5 and the x. So I'm going to end up using all 3 of the properties. And I'm going to start by getting rid of this fraction in my logarithm. So I can separate this out into the natural log of 5x to the 7th minus the natural log of y. And so the natural log of y is not going to change, but I can use the product property to separate this out and expand this some more. So because these are multiplied together, right? I can say this is natural log of 5 plus the natural log of x to the 7th. And then this natural subtracting of natural log of y is going to come down with it. To finish it out, this part's done. The natural log of 5 is done. The subtracting of natural log of y is also done. What I can do right here is expand this out using the power property. So this 7 is going to come out front, and then natural log of x. And that's the power property there. So that is the expanded form of the original expression. Looking at example 3, we are going to condense this logarithmic expression, and I'm just going through this, looking a little at a time, thinking about what properties I can use. Well, I know with the product property, right, I can take two logarithms with the same base that are being added together, and I can use the product property to condense that. I also recognize right here, at some point I'm going to use the quotient property because I have this subtraction. And I also see, I'm running out of colors, right here, right? That's going to be the power property at some point. Actually, I think that's where I want to start with this. So I know from the power property that 3 times the log of 2 I can rewrite as log of 2 to the 3rd power, right? This 3 becomes the exponent on the 2. So I can bring down the rest of the problem. And I know if I wanted to, I could clean up this 2 to the 3rd and make it an 8. And I might do that as I move into the next step. So now I'm going to work right here on this first part. And I'm going to apply the product property here. So I know I can combine the log 9 plus the log of 2 to the 3rd into the log of 9 times 2 to the 3rd. 2 to the 3rd I'm going to simplify to an 8. Right? And then I'm going to subtract here the log of 3. I'm going to close this out with the quotient property. This whole thing here, I know then that I can take, because this is a subtraction here, the quotient property would apply. So the 9 times 8 is going to be 72, and then it's going to be divided by 3. One last simplify then, 72 divided by 3 is 24. And then I could plug that very easily into my calculator since it's just a common log. Closing out the lesson then is just quickly reviewing again, changing of bases to the common log, or log base 10. Right? I can rewrite this as log of 8 over the log of 3, log of the big number 8, right? Physically larger than over the log of the 3, the little number on the bottom. And you see that explained here as well in generic form. This is what we talked about yesterday. This lets us quickly plug things into our graphing calculator. So I could simplify this over here as log of 8. Make sure to close off that parenthesis, divided by log of 3. Right? That closed parenthesis after the 8 is important. It tells the calculator to stop taking the logarithm and move into the dividing so that it separates numerator and denominator. So that would be your answer then to log base 3 of 8 if you needed that as a 1.8927 on forever and ever. So a lot of what we talked about today we will use when we move into solving the logarithmic equations.